Okay, I've been putting off making this video about my homemade valve spring compressor and tester. But after seeing a couple of low-tech versions on YouTube today, I figured I'd make a short video for now and then come up with one later on with a little bit more detail. But basically, I had a need to check some valve springs, some old valve springs, and compare them to the new ones. And I have access to a Remick valve spring tester. If you're familiar with those, it costs about $1,000, but they do a good job. And my homemade one is very close. Reads very close to the Remicks. But in any case, I had this half-ton Arbor Press from Harbor Freight, and it's enough to compress the spring, so I figured, well, let's see what I can do to make this work. First thing I needed was a load cell, which is down at the bottom, and that load cell is good up to about 440 pounds. It's a 200 kilogram load cell. I could measure the spring compression with that, but I also needed to measure the length of the spring, because they give you a length and a PSI reading to figure out if your springs are good. So in order to measure the length, I could either put a ruler, a scale, maybe a linear digital readout here, but what I decided to do was put a rotary encoder on the shaft that operates the ram. So I have the load cell on the ram, I have a digital encoder, a rotary encoder on the arm, so that when I move the arm, the rotary encoder will give us a readout. And let me do a quick adjustment here, and I'll put it right on the digital readout, which is a 4-line LCD. So you can see, set at the bottom, I have 0 pounds, but if I raise the ram, you can see it's 1.37 now, but all the way up, we're limited to a spring here of about 3.02 inches. Nobody's going to be measuring to that degree. So now the ram is just resting on the load cell. I put a slightly larger disc on the bottom of the ram so I can put the springs in it, and I can get them centered on the pad and on the load cell. So while we're watching the scale, I'll put a calibration spring from Remick. I'll put it in the center, and if I just rest it on there, I can see that that spring is 2.23 inches. It's pushing a little bit, but 2.2 is what we're looking for. So if I push this down to 2.2, the calibration chart shows I should have 12.7 psi for pounds. I have 13. The calibration chart, if I go down to 1.7, I should have 166.4, and I have 165. So that is pretty accurate. The spring specs usually say if you're within 10% of the PSI, then at a particular length, then you're doing good. So this thing is way less than that, and it measures up within a pound or two of the Remick scales. What's nice about this load cell is that it never compresses more than about 1/100 of an inch. I don't know how this works internally, but that's kind of nice. I don't have to allow for the load cell compressing, taking into consideration the length of the spring. It's going to be within 1/100 of an inch, so I'm not too worried about that. The rotary encoder is good for 2,048 points per 360 degree revolution. We're usually using about 90 degrees. So out of a quarter of that, 512 points out of 90 degrees, and if you do the math for the inches and the points per inch, then we can easily measure better than 1/100 of an inch with this thing. Let me back this up again. so we can look at the whole operation. So in a little more detail, and I'll put some of this stuff in the comments, but the load cell I got off, I bought the rotary encoder and the load cell off Amazon. I picked this one because it looks like it fits the bill pretty nice. I'll put the part numbers in the comments in case somebody else wants to do that. But both the rotary encoder and the load cell get fed into this little 3D printed box I made specifically for the display, but they connect up to these two operations. I get this in focus here. I have to do better with this. But what I use is a ESP32 S3 chip for the main processor and a load cell amplifier, which is an HX711, which are pretty common units. And with a little bit of programming that I found for both the rotary encoder and for the load cell, after chopping up a little bit of code from different examples, I was able to program the thing to give me the readouts in inches and pounds from the ESP32 and the HX711 and convert that to usable data. Pretty nice. The load cell cost about $50. The rotary encoder about 40. The chips are cheap. The HX711 amplifier, you can get a pack of 6 of them for like $10. And the ESP32s, you can find those for, I don't know, $6 or $7 a piece. I designed the box itself on FreeCAD and printed it up on a 3D printer that I've had for quite some time. I originally tried to use one of these guys. Now these things are hydraulically operated with a meter, and there's some fluid inside that thing, but that thing was nowhere close to be accurate. Up around 250, 300 pounds, that thing was off 50 or 60 pounds. So I don't see any way to adjust those unless you can compare them and test them out on a RIMIC or some kind of setup like this. You're kind of SOL. Post some questions if you want. I'll answer them if I can. I will post the part numbers, a little more information, and I have a site going on GitHub that'll have a little bit more information and the code. I'll post the code. Anybody wants to modify it, that's fine. Right now, all it does is read out, and I have a little button on top that works through the case. It's a capacitive touch switch that I can tear it so I can zero everything out. Either when I start it up, or if it looks like it's getting out of whack, you can set everything to 0 again. The code needs to be able to, let's say, change a load cell and then recalibrate it. And there's specific software that you can program in to make that happen. But I would like to program the ESP32 for a web server so you can connect your phone to it and you can do your calibrations that way. The calibration for the rotary encoder, once that's just strictly numbers in turns per inch, so you can just figure that out. That never changes. It's an incremental encoder, by the way, not an absolute. And I would suspect that if you change the load cells, there might be some calibration involved just in variations in the hardware. So it would be nice to be able to do a calibration either through my box or through the phone via a web server. So anybody wants to fool around with the code, have at it. That's it for now. That was a quickie, and I'll put more detail up either on added to this video, or you can find it on the GitHub, and I'll put that address when that's ready to go in the comments on the YouTube vid. See you later.